Hello my friends, this is 15th issue of the Weekly Links. I want to mention that this is the last issue in the first season of my show. Next I will make a short break for a couple of weeks and get back to you with a new show. I suppose it is not enough to talk about Java, it is necessary to finally start writing Java with you. So, we'll see. What's in the agenda today? A short article about building tool, formatting of logs in Spring Boot apps, and a few interesting jabs that hopefully can make our life better and easy way to keep our software up to date. My name is Alexander Barmin and this is my channel. Brew your morning coffee and let's get started. I want to start today's issue with the battle between Ant, Maven and Gradle. Okay, mostly between Maven and Gradle. But I'm old enough to remember Apache Ant. Have you ever used Ant? If so, please put like to this video and write a comment. Okay, about Ant. You know what? That to build Java application it is necessary to compile the code, process resources, create meta in folder, put some metadata there, archive the files into the jar file, and finally you have it. Next, you obviously can upload this jar to some storage. In case if you have dependencies, you have a separate step to put your dependencies to proper folder, update class path, and so on. Not easy. These steps are not complicated at all, but there are a lot of them in common. They should be repeated for every project. The complexity comes from the understanding that different projects have different structure. I remember I was working on the project which has multiple applications, and in some repository sources were stored in the folder called src, in other source, third, and also had code in Groovy, and I don't know why. The problem here is that code is structured differently in every project. It is not a problem on its own because you can update your Ant script and it will execute anything. The problem is that different projects have different structure, and also it is not easy to manage dependencies. The Apache Maven stepped in here and introduced convention over configuration. Long story short, it means that the software should work out of the box. You add pom.xml file and the vast majority of configuration is already done. If you follow conventions, you don't need to configure anything at all. I thought Apache Maven used XML, so that it's old because no one will use XML for configuration. It is not flexible enough. But time after time I understood that actually it is convenient because the configuration is the same for every project. It is also quite restrictive. You can't just go and shoot your leg, it is not allowed. Another important thing that Apache Maven introduced is dependency management. Yes, you don't need to download jar files manually, put them to the folder and resolve all of the transitive dependencies. You can just write a piece of XML and it will start to work out of the box. But now we have Gradle, and to be honest, I tried it multiple times. But what I found is that it is too flexible. Yes, it is the problem because you can't just start using it, you need to remember order of steps it executes plugin. You need to remember that plugin for build script are not the same plugin that used during the build itself. You also may write some customization in Groovy or Kotlin. In common, you have too many options and it is too flexible for most scenarios. Yes, if you write some framework like Spring Framework or Hibernate, you may need such level of flexibility. However, for majority of regular projects, it is just not required. So, time after time, I think that every task should have its own tool, and Apache Maven is the better option for the most of build projects. What's your view? Put your answers in comments. Moving forward. And now I want to talk about logging in Spring Boot apps. Before we get into the nitty-gritty of customization, let's talk about why logging is an essential component of any application. Logging provides us with a window into our application's inner workings. It's like having a behind-the-scenes tool that helps us understand what's happening under the hood. Whatever it's debugging an issue, monitoring performance, or gaining insight into user interactions, logging is our trusty companion. Spring Boot doesn't just give us the power to build robust application, It also equips us with rich capabilities to tailor our log outputs. One fantastic feature is the ability to export logs in JSON format. This JSON format provides to be a lifesaver when integrating with tools like AWS CloudWatch, Elastic Logstash Kibana, and others. The structured data ensures easy navigation and analysis of logs. Under the hood, Spring Boot relies on Logback for handling its logs. The magic happens when we create a configuration file named logback-spring.xml in the SRC main resources directory. This is where we can work on customization magic. From adjusting log levels to specifying appenders, we have the flexibility to mold our logging environment to suit our needs. Here is where Spring Boot shines ever brighter. It understands that different environments demand different log formats. With the concept of profiles, we can seamlessly switch between log output formats based on our application's running environment. For example, when your service is in production mode, we might want clean and structured JSON logs for efficient analysis. On the other hand, during local development, traditional logs might be more developer-friendly. Let's talk about fine-tuning log levels. Spring Boot grants us the power to configure log level for specific packages directly in the application.yaml file. This means they can crank up the verbosity for debugging purposes in one package while keeping other packages silent to avoid information overload. It's like having a volume control for different sections of your application's orchestra. I think it's good. More details and concrete recipes you may find in the article. Moving forward, and let's talk about collections framework. Within the collection framework, we encounter various types, each designed to serve specific purposes. One of the simplest and most familiar types is the list. Lists mainly order, allowing us to store elements in a predictable sequence. Implementations like ArrayList and LinkedList abide by this order, enabling us to access elements by index and maintain a sense of sequence in our data. Moving beyond lists, we venture into realm of sets. Sets introduce an interesting twist, so they can be both ordered and not ordered. For instance, HashSet, a common choice for its efficiency, does not enforce any specific order among its elements. On the other hand, linked HashSet and TreeSet take a step further by supporting ordered elements. This nuanced interplay between order and disorder is a hallmark of the collection framework. Amidst this intricate landscape, Java developers recognized the need for a more precise way to distinguish between ordered and not ordered collection types. JEP 4.3.1 introduces a revolutionary addition, the sequence collection type. As exciting as this innovation is, it's important to note that JEP 4.3.1 is still taking its first steps, and at the moment it's a promising concept that's being cultivated for potential inclusion into JDK 21. Let's continue by revisiting a familiar concept, static final members. These constants are usually declared to be evaluated at the moment a class is loaded. However, this eager initialization can be sometimes be a problem, especially when dealing with heavyweight objects or resource-intensive operation. Imagine the scenarios where you'd prefer to defer this initialization until the last possible moment. In Java, we have come up with ingenious workarounds to tackle this initialization challenge. One common approach involves using handler classes, inner classes that hold the actual constant value. This way, the heavyweight object isn't initialized until the holder class is accessed. Another technique is the famous double-checking mechanism, where we ensure that the object is only created when necessary. These techniques, while effective, can sometimes introduce complexity and overhead. But wait, there is a new kid on the block. Java Enhancement Proposal, which is in draft state now, computed constant, is an exciting proposition that seeks to simplify the way we deal with initialization. The idea? Introducing a new type in Java, the computed constant. This type would allow us to create constants that are lazy initialized, meaning the heavyweight objects associated with them won't be created until the first attempt to access them. Exciting as it may be, it's important to note that JEPT computed constant is still in the early stages. While it's not yet available in the mainline JDK, it is stated for inclusion in a future version, so keep eye on it. We all know the importance of staying current in the software world. Regularly updating our dependencies ensures we are benefiting from new features and crucial security patches. Yet, while this concept sounds great on paper, the reality of updating can be a daunting task, especially when it involves migrating to new versions of libraries. We've all experienced those moments when upgrading a library feels like navigating through the minefield of compatibility issues. Not all libraries are designed to be backward compatible, and we can't forget the monumental shifts like the transition from JavaX to Jakarta EE or leap from JUnit 4 to JUnit 5. These migrations can often introduce migrants. But fear not, for this knight in shining armor, Open Rewrite. This tool comes with a special plugin that can be seamlessly integrated into both Maven and Gradle projects, a quick addition to your POM.xml or build.gradle file, and you're ready to wield the power of simplified migration. Open Rewrite's magic lies in its ability to automate the migration process. Once the plugin is integrated, it is as simple as executing it. Open Rewrite will then comb through your code base, identifying necessary changes such as updating, imports, replacing classes, and more. This automated approach saves time and ensures consistency across your project. But wait, there is more. Open Rewrite isn't just one trick pony, it's a Swiss Army knife for code-base management. Ever wanted to replace Guava collection with JDK collection when feasible? Open Rewrite can do that too. It doesn't stop at migration. It is as of applying fixes identified through static code analysis, managing GitHub actions, and more. Open Rewrite's power doesn't end with the provided capabilities. If you have specific needs, you can write your own receipt. Whether it's a bespoke migration pattern or Unicode transformation, the flexibility is yours to harness. This adaptability makes Open Rewrite a tool that truly adapts to your project requirements. So, give it a try. That brings us to the end of today's video. I hope you found our exploration of the fascinating topics both insightful and engaging. If you did, don't forget to show your appreciation by hitting the like button and leaving your thoughts in the comment section below. Your feedback keeps the conversation alive and fuels my passion for creating valuable content. As I mentioned earlier, this marks the conclusion of this season, but fear not, for I'm not bidding farewell forever. I'll be taking a short break and then returning to your screens in just a couple of weeks with an exciting new show. In the upcoming season, we will going to tackle LeetCode challenges together, sharpening our problem-solving skills and diving deep into algorithmic conundrums. So stay tuned, stay curious, and get ready for another thrilling journey through the realm of programming. Until we meet again in the next season, I want to express my heartfelt gratitude for your support and engagement. Thank you for being an integral part of this community. Until then, take care, keep coding, and remember, every line of code is a step forward, shaping a better digital world. Bye for now.